In this video, we'll take a look at state and how it lets you describe changes to your UI using data in a technique known as declarative programming. Let's get started. One of the core features of React components is declarative programming. In simple words, changes to visual elements are driven using data. To understand this better, here's a typical user interface for a checkout screen on an online shopping site. Here you can see a list of items that the user has added with quantity and cost, and you can see the total amount at the bottom. If we separate the data from the visual elements that you see, then we'd get something like this. We simply have an array of products with the per unit cost and quantity purchased. This is the data that drives our interface. Changes to this data should update the interface and the calculations on the price. Now, let's say we want to add another product. This should be as simple as adding the product to the array on the left. This should automatically update the UI on the right. Pretty simple, right? Let's call this data layer as state. React uses the concept of state, which essentially describes the contents of the interface at a given time. Whenever the state is changed, the interface automatically updates to reflect the change. You declaratively update the interface by simply updating the underlying data layer, which is known as state. Everything else is managed seamlessly by React. This makes it really easy to imagine your application in terms of data and not in terms of technical nitty-gritties such as document object model or DOM manipulation, selectors, and other things that you would otherwise need to worry about when building a web application. Imagine state like a conductor to an orchestra. The UI plays what the state describes. You make changes to the state and your UI updates with it. React, as you know by now, provides us with two kinds of components: class components and function components. When using class components, state management is a built-in feature. This means you can create and manage state variables directly within the class component with no extra tools needed. The first thing that one needs to do is declare and initialize state properties. This can be done either in the constructor method of the class component, or if you're using the create React app based workflow, you can declare your state object using the class field declaration syntax as seen here. These properties are then directly accessible within the class's methods, including the render method using this.state.property name. Whenever the value of these variables change, the render method updates automatically, rendering the change on the screen. It is important to note that state is local and private to a component and is not accessible outside a given component. You can share a component's state with another component by using props, but in this case, the other component needs to be a child. In larger applications, we can use other strategies such as a dedicated state management solution like Redux. Manipulating state causes the component's render method to recompute so you can see the result on the screen. To manipulate the state, we must use the setState function. Here's how it looks like. You invoke this.setState in a method as seen here, and you can pass an object that updates one or more state variables. But a very important thing to note about the setState method is that it is asynchronous. Consider this situation where multiple invocations are made to set state. To ensure optimal performance, React may batch together multiple consecutive state changes into a single consolidated update. That is why, as a general practice and by default, you cannot rely on the value of the state to compute the next value of the state. So what about situations where you do want to rely on the current value of state for the next update? In such cases, React allows you to use this notation where you can get access to the state object and also props. The function here receives the current value of state, which you can then update as needed. When working with a large interface or an application, it is a strongly recommended practice to keep state at the nearest logical parent, from where it can be passed down to child components using props or a feature known as the context API. Keeping state at the nearest logical parent helps you manage and reason with state data changes in a much more logical way. Let's now see a simple example of using state in a class component. First up, download and extract the project from this link. Then run npm install to download and install dependencies. And finally run npm start to kickstart the hot reloading development server. On the right, you can see the output of our application. It is a simple to-do style application with an input field on top and a list of items below it. For rendering the list of items, we are using multiple instances of the item component, which requires us to set the name prop to the item that it should display on the screen. We'll render these dynamically using the state in a short moment. Our input field has an onKeyUp event listener, which is set to run a method called add. In this method, we are checking to see if the user has pressed the enter key on the keyboard, and if so, we want to update our state. But first, we need to create and initialize the state. Since this project uses the create React app based build system, I can simply create a state object like so. In this state object, I'll create an items array, which will hold objects, each representing an item in this list. Now that we have the items array in the state, we can use it to dynamically render instances of the item component here. So using a pair of double curly braces, we'll access this.state.items and we'll use the map method to produce instances of the item component like so. The I argument here will provide us with access to each object from the items array in the state. Each object will have a name and an ID property. So we'll pass I.name to the name prop on the item component like so. And since we are rendering multiple instances of the item component, we would also need to provide a key attribute with a unique value for every component instance. We'll thus set this to the ID property from the items object like so. We'll talk about the key property in a later video in this course. For now, this is all the setup we need to dynamically render our list of items from the state variable named items. I'll now manually add an object to the items array like so, and it pops up on our UI as expected. But we really want to wire up our input field to add items to the state array when the user presses the enter key. This will be done in the add method here. To update the state, I'll type this.setState and we'll pass in the state object with the items property set to an array. We don't want to replace the current items in the array. We instead want to add items to this array. So we'll use the spread operator to access and keep existing objects as is, and we'll then add an object where I'll set the name property to e.target.value, which gives us access to whatever the user has typed in the input field. For the unique ID value, I'll use the current timestamp like so. That's it. You can now type in the input field, press enter, and it instantly appears on the UI. As the state is updated, the render method is recomputed to reflect the change. This is declarative programming. You describe the UI by data in the state. As you saw in this example, state is at the heart of declarative programming in React. It describes the UI with data. The render method reacts to changes made to the state and keeps the UI in sync with the data. But is state limited to just class components? Can we incorporate state in function components too? Let's try to answer these questions in the next video.